So the session is entitled Enhanced Worker Safety in Process Industry Environments. Hybrid Location Technology is a Complete Solution. And our speaker is John Hartley. He is the CEO of Extronics. John?
Thanks very much, Mark, and thanks to everybody out there who's listening. We appreciate your time today. So just a few things about myself. First got involved with real-time location systems back in 2005 when we got involved with a company called Aeroscout. We were pioneers in Wi-Fi RTLS and also worked with Cisco. So I've got quite a lot of knowledge about deploying Wi-Fi based RSSI solutions in all sorts of heavy metallic environments. We've deployed solutions all over the world in all sorts of applications, and it's through this journey and it has that we've come to the conclusion you need to really be leveraging multiple location technologies to get an economical and practical solution. And we're going to run through that, some scenarios, and tell a bit of a story over the next sort of 20 minutes or so. I mean, one thing that I did realise is how slow the uptake was in the industry. We were very early in the market. That's clear when I look back. Being early meant we certainly have gained a lot of experience over the last 15 years. What we have noticed now is that it's becoming a more normal requirement to track assets and people. We do both. People tracking has been one of the things that we did focus on, though, because this was driven by the desire to make it easier to evacuate people from site. When workers were in distress, they could call for help and account for everybody. Plus, there are all sorts of other use cases as well. So, yeah, it's been an interesting journey, and we're excited what the next 5 to 10 years will hold for us, as this is part of the digitalization of the process industries that is currently underway. So I thought I'd just share with you a few customer requests that we've had over the years. And I'm not saying that these don't come up still, but there's certainly the early aspirations when the industry was looking at it was, I want to track all my people and my assets to sub 1 meter accuracy in 3D. A really noble and great aspiration. But how much is that going to cost? It's certainly possible, but is it necessary? My battery life should last forever, really. I think that's what everybody would love. They'd like an active tag to have an infinite battery life, but certainly 5 years or 10 years is something that comes up quite regularly as a requirement. The solution should be low cost with little or no infrastructure to deploy it. It's also got to work in the most arduous environments, harsh environmental conditions, as well as heavy metallic structures, which of course play havoc with radio frequency signals with multipath reflections. And then the other one that's quite common certainly for a safety system, a personnel tracking system where you're using it to enhance worker safety, is I want 5 nines uptime, you know. And that's an easy thing to ask, and this is, I suppose, the message. These sort of questions, these points, they're easy to say, but they're very, very difficult to actually achieve, or much harder than people think. And there's always a trade-off, always a trade-off. So everything's possible, but actually, can you afford it? And the other point we always say is, do you really need it? So, in the process industries, we're talking about oil and gas facilities, chemical plants, steel works, waterworks, you name it, it's that continuous processing sort of industry. Mining comes under that as well. There's an awful lot of potential risks for workers, and they could include anything from fire, explosions, falling, medical emergencies where people are just through fatigue, for instance, could be a problem. Risk of getting crushed, all sorts of issues around confined space entry, and there are procedures and processes around managing those, but often they're quite old-fashioned and require people with clipboards and that type of thing. So these issues have always been there, and they've been managed with quite manual processes often, or having two people to do one thing so that you have a buddy there to look out for you. Flammable and toxic gases and dusts are also present, quite common, and things such as extreme weather, for instance, in some of the most difficult parts of the world where they're getting minerals and oil and gas out of the earth. They're not always in the most hospitable of places, let's say. So we then look at what are the operational challenges. These are the sort of things you've got to consider when you're selecting a real-time location system for protecting your workers or tracking your assets. One of the things that still surprises me today, in my naivety, and I hold my hand up there, I thought in 2005, when we embarked on this journey, that by now, basically all the process plants of the world would be tracking all the people for worker safety. I do believe that will happen. And it just took a long time to get to the point where it was decided that this would be a useful and requirement. And so many companies are still using pretty much old-fashioned process and procedures to account for people. I still see signing in books, T-cards, parts and access control system is perhaps the most frequently used now, with an automated headcount sort of function added to it. But very rarely do you see enhanced worker safety solutions, with emergency call, automatic mustering, fall detection, with lone worker facilities and gas detection, that type of thing. They're becoming more common, that you would start to see them, but these are certainly not the norm. When you start looking at some of the other challenges there, like I say about confined space entry, if you use modern technology, you don't need a person on every entrance to a confined space. You can do this using automated tracking technology with remote monitoring using cameras and things like that. Worker accountability is also useful for compliance and security purposes, as well as making sure a plant's safe and unqualified workers are not going in to a part of a plant where they don't have the right credentials. And slightly controversial, you could say, is productivity monitoring, especially in turnarounds or large construction projects. Because, let's face it, you're paying for a huge number of contractors to come on site to do a fair day's work. And you do need to be making sure that that's actually happening. Otherwise, a huge amounts of time can be burned and be unproductive. And there are some well-documented papers out there where some of the companies have been using our technology to vastly reduce costs in large construction and turnaround projects. So we move on next. When you're considering your technology to do these things, your environmental challenges that you've got to deal with. As we sort of, I think, all acknowledge and recognize, when you're in a office or a warehouse-based environment, or a factory, for instance, it's pretty much a standardized space. You're dealing with the same infrastructure and challenges, So it's easier to design an RTLS system and probably economically viable to choose a specific location technology and just deploy that everywhere. Not really the same in the process industries as such. I mean, the sites are huge. Some of the sites, if you're looking at, for instance, in the Canadian oil sands, you could be looking at sites covering 20, 30, 40, 50 square miles. Move over to a very large petrochemical facility, which can be anything up to 10, 20. We're even working on one at the moment that is 35 square kilometers. So these present very many operational challenges because of the vast size, but you've also got a lot of indoor spaces. You have vast outdoor spaces, you know, like where you've got tank farms and things like that, spaces between each processing unit. You have all the heavy metallic process units, which are just very dense metal, huge structures, and often you can't see more than a few meters into them because they're a mass of pipework, stairwells, bulkheads. So they do present the most challenging environments to deploy real-time location system technology. You then throw in hazardous area as well, so potentially explosive atmosphere, and as Mark said earlier on in his presentation, he then starts to limit the choice of equipment because it is more specialized. There's less market opportunity for this, so therefore there are less vendors that provide for it. And it does present challenges as well with trade-offs on the type of equipment capability, because often you are making an intrinsically safe device, you've got to limit the power in it. Sorry, I'm just getting a lot of feedback there. Perhaps it's getting quieter now. I'll carry on. Also, things such as the amount of workers that are going to be on site can be huge. So you do have to consider the scalability and how often things are beaconing and so on, because this can affect this type of system that you choose. So this slide I quite like in that it visualizes some of the different location technologies that exist today. And the trade-offs, because that's the rub, really. Life is a compromise. Often it's the same with technology. There's a phrase, you rob Peter to pay Paul. That might be familiar to some people. And that pretty much, I find, follows through when you start looking at real-time location systems and some of the trade-offs you make. So let's take a look at GPS. Well, we all are really familiar with GPS. It's probably the most familiar location technology there is to the general public because we all use it in our sat-navs and in our smartphones. And it's so widely available. It's fantastic technology, really. It's amazing how it works. But it's not always as accurate as people think. It's very much affected by plant structures and buildings and so on. And it's only through sat-navs and things that their software corrects for some of this. For instance, when you're driving down a road, it won't put you in a field when it knows you're on the road. So some of these things are hidden, so you can be sort of surprised at just how inaccurate a GPS can be in certain conditions. The other big highlight here, though, is that its battery life is very poor. You will not find people stating that they have a several-year battery life with a GPS tag that's going to be giving frequent location updates, and by that I mean every 30 seconds, that type of thing, which is a key requirement for worker safety and personnel tracking. not unless the battery is that huge, you would need perhaps a wheelbarrow to carry the battery around with you, or a rucksack. The good thing about GPS, of course, is there's basically no infrastructure from the location aspect. It just needs connectivity to get the location data back to the software visualization system. It's certainly one of the most popular location technologies. Now, we touched upon Wi-Fi as a geolocation technology, and also I meant referring back to the question we had earlier. And you see in my table, I'm putting the accuracy between 5 and 25 meters. And I'm saying the typical range of a Wi-Fi tag would be, say, 150 meters. But all these things are all interlinked. So as Mark rightly said, you need a really, really dense infrastructure before you can actually get anywhere near 5-meter accuracy. 3-meter accuracy is possible, probably in certain locations. Also, depends on whether it's in open space or whether it's actually in buildings. Better in buildings, because walls and things like that help give a change in the received signal strength. But we typically position Wi-Fi location accuracy around the 5 to 25 meters. And the reason we put it into that sort of bracket is because of where it's practical from the point of view of how many access points that you really are going to deploy before it starts actually becoming a problem where they're interfering with each other. So it's certainly pretty good on battery life. Depends on whether you are beaconing, because there are Aeroscout and Cisco are the two vendors who have the patented Wi-Fi beaconing, and this is much better than sending an IP address connectivity from a battery perspective. So battery life can actually be anything from sort of poor to very, very good, depending on whether you're beaconing or not. We then get onto radio technologies that are based around 802.15.4 standard, like the Zigbee type radios that when they first came out. Wireless Heart and ISA 100 are running on these radios, but they can also do RSSI based location. Any RSSI location, they're all pretty much the same in their level of accuracy. And the way I position RSSI location to customers is it's pretty poor. Yeah, because there's so many variables. Just even the human body will shield by several dB when you're wearing a tag. So it's definitely useful, but it's certainly not super accurate. Those type of radios as well tended to have quite a lot of proprietary solutions, came out a decade ago. Battery life's pretty good, but again, dense infrastructures required. The really interesting technology that came out a few years ago, and by a few years ago, I mean the Decawave-based chipsets, ultra-wideband. It made ultra-wideband affordable and mass market, and you know it can do sub 10 centimeter accuracy. I say less than 1 meter, and I'm talking again about the perspective of a process plant, not ideal laboratory type conditions. It is fantastic accuracy, it is great battery life, but to get it you need a very dense infrastructure. Realistically, if you're going to be getting sub 1 meter, you're going to have to be putting gateways every 15 to 20 meters. And another caveat is to show that where you here we say that the battery life's great, we're talking from the tag perspective when you have fixed infrastructure gateways connected to Ethernet to the network. And the reason for that is the gateways are powered. So the tag only has to beacon. There are alternative solutions where you get battery-powered location anchors, they tend to get called, and the tag receives the signal from those. So actually the tag's listening all the time. Then your tag battery life is sub 2-3 weeks, something like that. So that's that robbing Peter to pay Paul scenario that we talked of earlier. You move the problem from one place to the other. I mean, really, there isn't a silver bullet to location tracking. Be great if there was, but that's just not the reality of things. A very, very common location technology, because it's in every smartphone and all sorts of devices over the years, is BLE. And BLE has receives signal strength location ability, and there is angle of arrival. This has been done by a couple of companies. One of them, Cooper Technology, based in Finland, do it really well with their angle of arrival. They can get ultra-wideband-like accuracies. So it really does have a place to pay there. With BLE beacons, so you can put battery-powered beacons all over your site if you wanted to. You then got to consider maintaining those beacons and changing the batteries. And again, your tag itself would then be listening, so that would have a poor battery life. Or you can put in gateways, BLE gateways that are permanently powered, and the tags will last 5+ years on the battery. And passive RFID is still worth a mention. I say typical accuracy here in the sort of sub 3 meter range, and by that I'm referring to, say, using a UHF passive tag with readers at certain portal scenarios, entrance and exits, that type of thing, hence the accuracy of 3 meters. And especially if you wanted, you wouldn't deploy UHF readers everywhere to get 3 meter location accuracy. It just wouldn't make any sense and would cost too much. So they tend to get used for choke points. So yeah, a lot of talk on that slide, but it's just to highlight that there really is no silver bullet to some of those earlier questions that I shared with you right at the beginning of the presentation. It would be great if there was. So that's why we concluded, after many years of going out there with our Wi-Fi based real-time location systems, which work great. We've got some huge installations with major well-known companies in all parts of the world. But what the customers realized after these deployments was, ooh, good grief, it's a bit pricey to be putting out Wi-Fi to the density that's required to get sub 10 meter type location accuracy. So this got us thinking that we really needed to look at a hybrid solution. Because actually, you know, I mentioned about ultra wideband. You could put that across your complete plant if you wanted. That'll give you your 1 meter in 3D, but I would wager that the finance director at the company won't sign off on the bill for the capital investment, because it's just the infrastructure would be huge, and there isn't really the justification to be locating people down to that level across a plant. There's not the business case. So the need for this hybrid location technology is to try to solve the challenges that are there, which is one, the cost of the infrastructure, to keep that to a minimum, to deliver the right level of location accuracy in the areas that it is required, and in other areas where you don't need as much location accuracy, you perhaps use a different location technology or put less infrastructure in. And that is the essence of the route we've taken, and it's not surprising that other real-time location system companies in our space have come to the same conclusion, which means it's been validated. It's not just Extronics who are thinking that this is the right way forward. And when we, oops, what's happened to that slide? Here we go. So if we look at our hybrid location solution, what we've done, we've basically added in 4 location technologies into one tag. Those technologies are Wi-Fi, GPS, BLE, and low-frequency exciter. And each provides different functionality for different type of use cases. So one of the big challenges we have with a Wi-Fi based only type solution is the majority, I would say 80–90% of the plant have quite large open areas. There's the tank farms, there's a space between the processing units and so on. And you want to really leverage GPS there, because that will provide you typically sub 5 meter location, and all you need is connectivity to get that back. And as I already mentioned earlier, our beacon will go well over 200 meters, in fact several hundred if we're in open space reliably. So you really don't need much Wi-Fi infrastructure for the connectivity there. So it really reduces the price to get sub 5 meter. You then got to consider another use case. We want to automatically muster and evacuate the site. So one of the things that we tend to use there is the general Wi-Fi network, because that works everywhere. We're using the Wi-Fi network for providing man-down type functionality, emergency call. When you go to a muster point, we would look for using low-frequency exciters, typically, to instantaneously, as you reach the muster point, make the tag blink and beacon so that you know that you've arrived safely at a muster point. And then, of course, if someone unfortunately doesn't turn up at the muster point, they're missing, you don't have to search your whole site blindly. You pretty much know where they're going to be by looking at your solution. The use of BLE and low-frequency exciters. So BLE, by that I'm meaning BLE beacons, and I'll come on to the other point about angle of arrival later. But for instance, in BLE beacon, if you've got a dense processing unit or an indoor area, you can't use the GPS clearly. It can't see the sky. So we need some other type of location sources. Battery-powered BLE beacons are very economic to disperse and install in locations around a site. And these then, the signals will be received by the tag, and triangulating the receive signal strength allows location approximation. We also can utilize Wi-Fi. That's been deployed a lot now in the process industries. Typically in a process unit, you would need to put Wi-Fi certainly every 40 or 50 meters as a minimum. Otherwise, you won't even get decent connectivity for your mobile worker type strategy, where you're using tablets and smartphones or video collaboration equipment, for instance. So you can seriously leverage the Wi-Fi for location in those areas. And then low-frequency exciters working on 125 kilohertz, great for those choke points. I've gone up that stairwell. I'm on this particular floor, so it helps with floor separation as another possibility of using that technology. And then we come finally on to ultra-wideband, yeah, or BLE angle of arrival. Now, we don't use ultra-wideband in our solution. Not that we couldn't, but we've got BLE, and as I mentioned on the previous slide, there are gateways now which can measure the angle of arrival of a BLE beacon signal, which will locate to similar accuracy levels as ultra-wideband. So we chose to stick with that rather than adding a ultra-wideband transmitter receiver onto our product. Where you would use that typically is where your use case definitely supports the need for sub 1 meter location. Other than that, it's not really a requirement. Typically on a large site, if you've got sub 10 meter location, it's more than adequate to cover the worker safety use case. So what drove us to do this was the costs of deploying dense Wi-Fi to do the real-time location. And just to give you a sort of feeling, I mentioned a site where we've got about 30 square kilometers, and the original estimate was over 15,000 access points required to do sub 10 meter location. With our hybrid solution, 1,400 access points are required. And also, remember, those access points are not just used for the location tracking, they're used for the data connectivity. But it's roughly a factor of 10, yeah, of infrastructure reduction. So, you know, realistically, hybrid location technology is the way forward. It allows you to utilize the right infrastructure, the right technology to provide the best value solution. That's really the sort of message there. And just briefly, as we near the end, this is what our relatively new product looks like. We launched it a few months ago, and it's a purpose-built, highly rugged worker location tag with sensors in it, fall detection, emergency call. We've even integrated access control. That's another subject matter where customers were saying, don't want to carry two things. I also want them integrated. And we've integrated the access control cards using the common standards, even HID, the global leader in that. So that's also possible. And photo ID, these are sort of pretty standard things that you want in a worker identification badge. And the key other thing we learned is product durability, because the environments are very arduous in some of the cases that we work in. Quite topical and really just worth mentioning to let the audience know that we're actually adding in a solution to do social distancing and contact tracing. Again, this isn't unique. There are lots of companies, real-time location system companies, that brought solutions out really, really quick. We were not able to do so as we were quite busy with some other developments, but also didn't feel that the demand was initially there. We're starting to see, and we're getting asked by customers for solutions to do this. The technology we use here, pretty much we're using BLE like many others. And the BLE is radio's beaconing. It's also listening, and using receive signal strength, you can measure the distance between two people and again store the encounters. Ultra wideband is the other technology that we're seeing that used quite a lot. So yeah, this is going to be available, the new social distancing and contact tracing, starting in January. And an interesting point, we weren't sure, do we think that this is going to be something that comes and goes? some of the surveys that we've done, a couple on LinkedIn recently, more than 50% of customers actually think that some form of social distancing and contact tracing functionality is going to be a requirement in a worker tracking system beyond the current pandemic. It's happened once, could happen again. Depressing thought, I know, but one not to dwell on. And finally, just to finish off, I've written a white paper which may be of interest to people. It does come to quite a few pages. That white paper covers all types of location technologies and the whys and wherefores, and goes into a little bit more detail than I have done here. Some people might find that useful. And then, of course, all the marketing information that you would expect on our product ranges, on our website and YouTube and all that sort of stuff. So thanks very much. Really appreciate your attention, and hopefully there'll be some interesting questions which I've not had a chance to look at, but that will be great if there are.
Thanks, John. We have time for a couple of questions. You mentioned UHF RFID is a low-cost application. What about the reader cost?
Yeah, I mean, a great question, but UHF is fine, but you would only then be able to do what I would call choke point. You know, I've gone in that portal, in that door, so I'm in that zone. Deploying readers every 10 meters clearly is not economic at all. So that's why you don't tend to find UHF RFID used for what I call a real-time location system, and you've got to be careful there in the connotation of what real-time is, because of course it does read the tag in real time, but what I mean by that is being able to track all over your site to say sub 10 meter location. So you don't see it deployed too much. And also UHF RFID body shielding can be a problem with where you wear the tag. Can be an issue as well, with it being read. So especially if you're running through a portal, that type of thing, because there's an emergency evacuation going on.
Okay. Do you have an Extronics representative in Latin America, Mexico primarily?
We have partners based in North America. We've opened our office recently in the Houston area. If it hadn't been for COVID, Chris Sadler, who's our business development manager for the Americas, would have been resident there by now. So the answer is pretty much yes. We have representation over in that part of the world.
Okay. Any insight into the Wi-Fi 6E and UWB interference in the 6 gigahertz spectrum?
Ooh. I'm going to have to say I can't comment on that. I mean, our experience at UWB is, as I sort of said, was sort of peripheral. So I'm not qualified to comment, but I think that there's obviously something there. Yeah. Otherwise, the question maybe wouldn't be being asked. So sorry, I can't answer that. It's something that I'm prepared to take offline now, and certainly see if there's people that I know who can answer that better.
Okay. Can you comment on ICAR certification?
I'm not 100% what it is. I imagine it's some radio approval. So
yeah, I don't know what it is either.
Yeah. Okay. That's comforting for me, Mark.
Okay.
Well, it's not just me. I was just quickly ICAR certification.
Yeah, it's okay. We can take it offline.
Yeah.
Last question. How do you deal with the challenges of union acceptance and data privacy?
Oh, that's a really great question. Because quite frankly, people are always suspicious of Big Brother, because that's how people see personnel tracking systems. Not the same for assets, obviously, but personnel tracking systems has been that resistance from the unions. Generally, a couple of things. One, it's how you use the data. It's why are you tracking the people, and what are you using it for, and how are you using it. So if you're tracking for people's safety, then a lot of workers get it, and workers have actually asked for solutions when they've seen the tragic scenarios happening sometimes when plants have big issues. So we've seen that have resistance to actually embracing it. The other one, I think, perhaps more controversial, so safety is easier to justify, is productivity analysis and monitoring. But that can be done, for instance, anonymously. So you monitor a group of workers, perhaps from a particular contractor. And it's how you use that data with the contractor, and you show them, hey, how come it takes you 30 minutes to get to the workplace when you start the shift and only 5 minutes to get from the workplace off-site when you end the shift? And you find that alters the behaviour, and it's identical then. So as long as you don't use these things as a beating stick, I suppose, and you use the data in the way it was intended, which is to drive improvements and increase safety.
Right. Okay, John, thank you very much for a terrific presentation. That's all the time we have.
Yeah. Thanks.